The story begins not on the surface of the Earth, but deep within its quiet, ancient layers. Buried in stone older than imagination, scientists have found something that should not exist. Tiny metallic spheres, perfectly shaped, sealed inside geological formations that date back 65 million years, the very time the dinosaurs vanished in the cataclysm that marked the end of an era. To the trained eye, these are not ordinary deposits. Under microscopes, these spheres reveal a precision that defies random natural formation. They are uniform, symmetrical, balanced as if crafted rather than born of chance. Each is composed of metals rare on Earth: platinum, titanium, iridium, elements that in known natural processes rarely occur together in such purity. When tested, the chemical distribution across their surfaces does not match what volcanism, meteor impacts, or slow mineral crystallization could produce. Something else shaped them, something operating far beyond the known rhythms of geology. Yet these objects rest beneath layers of sediment, undisturbed for tens of millions of years, long before any recognized human or pre-human civilization walked the Earth. Their discovery raises a question so large that most hesitate to ask it aloud. Were we truly the first technological species to emerge here? Or could there have been others, long erased by the deep mechanics of time? The samples themselves tell a story written in metal and mineral. Their composition suggests that they were exposed to extreme heat and energy, comparable only to industrial furnaces or meteor impacts of extraordinary force. However, natural impacts tend to scatter debris chaotically. These spheres, in contrast, display uniformity that implies control, a process directed, repeated, refined, a pattern of intelligence, perhaps. Scientists remain divided. Some attribute them to rare crystallization under unknown conditions. Others quietly admit the data does not fully support that view. High-resolution electron imaging reveals microstructures resembling engineered alloys, rather than random associations of atoms. The idea unsettles. If these spheres are artifacts, who made them? And how were they buried so long before our kind evolved? The evidence pushes at the boundaries of accepted history. It suggests that high temperature, high pressure, and deliberate shaping once occurred in a prehistoric epoch where, according to textbooks, only primitive ecosystems existed. The implications are staggering because they hint that advanced activity may have touched the Earth in ages we consider purely natural. This is the first visible crack in the Great Wall of Assumption, the belief that human civilization represents the only moment of technological expression in our planet's story. If these spheres were indeed crafted, their makers lived and vanished before the continents took their present form. What force, then, erased all trace of their existence? Or could their presence mark the fingerprint of something not born of Earth at all? Even the skeptics admit that similar spheres cannot be produced by known geological pressures. Their symmetry resists explanation. Their alloys defy the ratios expected from molten rock. To create such balance requires equilibrium across heat and motion, conditions typical of controlled foundry environments, not random natural chaos. The more one studies them, the more they mirror design. Wherever scientists dig deeper, the mystery seems to grow. In strata far older than humankind, pockets of material appear almost deliberately placed, as if remnants of activities lost to erosion and time. Each discovery comes wrapped in silence from the stone itself, the mute testimony of something ancient and purposeful. These quiet clues whisper a story that might redefine what it means to be human. They force us to look again at the timeline of intelligence, not as a straight line leading to us, but as a cycle: creation, rise, and erasure, repeating through deep time. Could another civilization have mastered technology long before our species had names for the stars? If so, what became of them, and why did nature bury their work so completely? Every metallic sphere, every anomaly found in the Earth's oldest layers, functions like a locked door. On the other side lies an understanding our history does not currently allow. Some scientists warn that to interpret these findings as artificial would rewrite the story of evolution and civilization entirely. It would force us to rethink archaeology, biology, and even the timeline of technological possibility itself. And yet, curiosity persists. The deeper we look into these geological archives, the more the data refuses simple dismissal. The Earth's crust is vast, but it is not infinite. It remembers every process that has ever touched it. What else lies hidden, waiting in the depths, disguised beneath names like mineral inclusion or unexplained metallic anomaly? As we begin to peel back these ancient layers, the line between natural history and forgotten industry blurs. The forbidden evidence found here challenges not only science but philosophy itself. Because if intelligent hands once shaped matter at a time when no human species existed, then the story of life on Earth is far older, more complex, and more mysterious than we ever dared to believe. This is only the beginning, a whisper from stone, a question carried across time. And as we follow these clues deeper into the record of the planet, each part of this investigation will lead us closer to an even greater revelation. The Earth may not only host memory of life, it may also hold memory of civilizations long vanquished, leaving behind fragments we are only now learning to see. We uncovered metallic mysteries buried in the Earth's ancient layers, reminders that perhaps our world has witnessed more than one age of intelligence. But the stones do more than hide material traces. They also record stories written in the language of atoms. Deep within every layer, the Earth keeps an unbroken memory of its own transformations, sealed not in symbols or artifacts, but in isotopes, those subtle variations of elements that serve as the fingerprints of time. Every atom carries a signature, a balance between protons and neutrons that reflects where and how it was formed. When these ratios change, they encode the history of planetary processes. Volcanic eruptions, asteroid strikes, glacial thaws, and even the chemistry of life itself. To study isotopes is to read the diary of the planet, page by page, layer by layer. And when scientists turn those pages, they sometimes find entries so strange that even the most seasoned researcher hesitates. Among the most striking of these records are the isotopes of carbon, carbon-12, carbon-13, and carbon-14. These are the key instruments in measuring biological productivity, atmospheric balance, and the presence of life. In stable epochs, the ratio between these isotopes follows predictable rhythms, governed by natural cycles of birth, decay, and renewal. Yet in several ancient layers, these patterns break. Massive, sudden distortions appear, as though something unleashed an enormous pulse of carbon into the atmosphere, overwhelming all normal processes. The most famous example lies 252 million years ago, a point geologists call the Permian-Triassic boundary. It marks the greatest extinction in the planet's history. More than 80% of marine species and a majority of land organisms vanished. In those rocks, scientists have detected enormous carbon isotope anomalies, spikes and drops that signify the rapid release of carbon dioxide on a scale so vast that modern human activity seems small in comparison. To release that much carbon would require the combustion of nearly every reserve of coal, oil, and natural gas we know, and yet this occurred hundreds of millions of years before our species existed. The cause of that ancient catastrophe remains debated. Some propose volcanic outpourings from the Siberian traps, where titanic eruptions could have covered millions of square kilometers and burned through immense quantities of organic matter. But others point to chemical patterns that do not align neatly with such explanations. Uranium and plutonium traces appear in some samples, their isotope distributions subtly inconsistent with natural decay patterns. They suggest processes involving neutron interactions at levels rarely seen outside of controlled nuclear reactions. Such findings raise questions too large to fit comfortably within known frameworks. Could these anomalies indicate not just geological crisis, but technological or industrial disruption of a kind forgotten by time? If a civilization complex enough to manipulate matter existed before us, its last mark might not be cities or machines, but changes in isotope balance, a planetary scar visible only to science tens of millions of years later. The Earth, in this view, is not merely our home, it is an archive that forgets nothing. The rock layers may bury biological remains, but they preserve the chemistry of every era. when carbon levels spike, when oxygen ratios collapse, when uranium shifts its isotopic pattern. These are not random phenomena. They are signatures of events so immense they reshape the entire biosphere. Some such spikes correlate with mass extinctions, when entire ecosystems perished almost overnight in geological terms. As scientists piece together these isotopic puzzles, they begin to see unsettling parallels with our present moment. The scale of carbon release during ancient cataclysms mirrors the rapid rise we now cause through fossil fuel combustion. Past epochs of carbon-driven warming led to ocean acidification, widespread anoxia, and the collapse of complex food chains. Each event marked an evolutionary reset. Life eventually recovered, but it emerged transformed, its earlier forms erased. It is here that the mystery deepens. In some sedimentary deposits, isotope deviations coincide with trace elements that suggest high-temperature reactions more focused than any volcano could sustain. Platinum group metals, strange ratios of thorium to uranium, and peculiar concentrations of rare earth elements indicate processes of separation and refinement, hallmarks of chemistry with direction rather than chance. Though natural explanations are always sought first, there remains a haunting possibility. Perhaps what we interpret as natural devastation was the aftermath of something else, the collapse of an industrial epoch long vanished. Imagine a civilization deep in prehistory, rising under different skies. Their science might have followed unique paths, their technologies unlike ours. Yet if they mastered energy, metallurgy, and carbon manipulation, their fall would leave geochemical traces strikingly similar to those we now record in our own industrial age. Perhaps their factories burned, their cities turned to dust, and the carbon they once consumed returned to the air in a wave of extinction that only isotopes remember. Most conventional scientists reject such speculation, insisting on natural origins for every signal. Still, the data's complexity resists full closure. The isotopic record does not lie, it merely waits for the right questions, and as our understanding of Earth systems grows, the resemblance between past and present becomes impossible to ignore. Catastrophe, it seems, may not be a rarity, but a rhythm, and intelligence, a brief fire between cycles of forgetting. The planet remembers everything. Its stones are not silent, they whisper. Beneath their calm surface lies a chronicle of destruction and transformation, each entry marked in the fine language of chemistry. When we read that story carefully, we begin to sense that humanity itself has an older reflection. Civilizations that may have burned bright before being buried beneath their own consequences. If so, our modern world might not be the first to push the Earth past its natural thresholds, but merely the latest to test the patience of time. And so, we are drawn deeper into the riddle. If metallic spheres whisper of impossible craftsmanship, and isotopic records tell of inexplicable upheavals, what else in the ancient Earth may testify to forgotten mastery? Could nuclear traces hidden in the crust hint at forces once deliberately controlled? The answer may lie ahead, where nature itself became both engineer and witness, a revelation remembered in the scars of uranium and the quiet pulse of radiation within our planet's oldest stones. In the layers of the Earth we have found strange metals that defy explanation, and isotopic scars that speak of ancient transformations too immense to be forgotten. But now we arrive at a place that stands as both a miracle of nature and a haunting echo of something perhaps not entirely natural. Deep within the soil of Gabon, West Africa, lies a phenomenon that stunned physicists when it was first discovered in 1972, the Oklo Natural Nuclear Reactor. Here, the Earth itself once performed controlled nuclear fission, a process identical in principle to what human reactors achieve today. Buried 2 billion years beneath our feet, this natural reactor operated with precision, sustaining chain reactions for hundreds of thousands of years. It released energy steadily, moderated by groundwater serving as a natural control mechanism. To this day, it remains the only known example of self-sustaining nuclear fission beyond human design. When French scientists at Oklo began analyzing uranium ore for enrichment, they expected to find a standard concentration of uranium-235. Instead, they discovered that it was significantly depleted, exactly as it would be if it had undergone a long chain of fission reactions. In other words, the ore had already served as nuclear fuel. At first, the possibility seemed absurd, yet deeper investigation revealed fission product isotopes in precise ratios, proving that the reactions had indeed occurred. The Earth, it seemed, had once built its own reactor long before humans appeared. This discovery changed everything. It demonstrated that nuclear power, usually considered the pinnacle of modern engineering, can arise under rare but natural conditions. It also introduced an uncomfortable question. If nature itself can orchestrate atomic balance in such a controlled way, then how confidently can we distinguish between natural and artificial nuclear signatures found in the geological record? The boundaries blurred in that moment, and curiosity turned to unease. The Oklo site became a laboratory of deep time, proving that the balance of uranium and water could sustain energy release through natural moderation cycles. Yet, while the Oklo phenomenon was natural, it was also unique. Nowhere else on the planet have geologists found conditions quite so perfect. The isotopic ratios of uranium-235 and uranium-238 provide a clear fingerprint of this process. The predictable pattern of fission byproducts serves as a baseline, a reference point for what nature can achieve on its own. But when scientists began surveying other uranium deposits across different continents, they occasionally stumbled upon isotope configurations that did not line up perfectly with natural fission expectations. Slight shifts in the distribution of xenon, neodymium and samarium isotopes suggested energy reactions either more intense or more localized than any geological process could easily sustain. Such variations lead to an unsettling speculation. Could some of these anomalies reflect remnants of events that were not purely natural in origin? The question may sound fantastical, yet the logic is simple. Artificial nuclear activity leaves behind unmistakable signatures, patterns of isotopic decay, ratios of transuranic elements, and the presence of synthetic nuclei that resist natural formation. These remnants would persist for millions, even billions of years, long after any surface evidence vanished. If an advanced civilization once harnessed nuclear energy, its ghost might still radiate faintly in the crust of the Earth, encoded in the isotopic script of its own extinction. What if the planet's own layers hold evidence of such experiments? Some researchers propose that unexplained traces of radioactive isotopes found in ancient sediments might connect to this possibility. For example, certain samples reveal anomalies in uranium-lead dating curves, suggesting the material was once altered by external energy input. Yet mainstream science, cautious by necessity, attributes them to local chemical variations or sampling errors. Still, the mystery endures. Each new anomaly forces the same internal question. How much are we interpreting through the narrow lens of the present, forgetting that time may have eroded more than just matter? It may have erased entire chapters of context. The Oklo phenomenon offers a lens to re-examine everything else. It proves that high-energy nuclear reactions can occur without human design. But if nature can mimic the work of technology, could ancient technology once have mimicked nature so perfectly that now it passes for geology? Imagine a reactor built by an intelligent species deep in the past, its components long decayed into mineral structures, its energy source burned away, and its memory sealed beneath pressure and age. The isotopic residue might look not entirely different from natural Oklo, yet remain subtly distinct. We would be left staring at the evidence without recognizing what it truly implies. Some physicists, studying the isotopic subtleties of certain uranium deposits, note deviations that are precise but inexplicable by random variation. They resemble deliberate calibration, energy patterns that reach criticality and then stabilized in ways suggesting containment. Others dismiss such thoughts, insisting there is no need to invoke advanced causes when rare coincidence might suffice. But the question lingers like radiation itself, invisible yet persistent, spreading through the imagination of those who dare to wonder. If we accept that the Oklo reactors were entirely natural, we still face an equally profound realization. The same Earth that can spontaneously generate the power of stars can also bury traces of that power beyond recognition. Whether natural or engineered, the planet is capable of erasing evidence through time's relentless cycle. In that sense, even unmistakable signs of intelligence might eventually appear geological to the distant future. The implications reach beyond curiosity. If civilizations, ours or any before, wield nuclear mastery, the consequences persist eons after the reactors fall silent. Radiation decay follows no calendar of human survival. Synthetic isotopes whisper across time, unaltered by extinction or memory. Thus, the Oklo discovery is not only a scientific curiosity, but also a metaphor, a message written by the planet itself. It shows how energy, knowledge, and consequence intertwine across ages. Connecting to the isotopic anomalies we explored earlier, one might now ask, were those patterns in ancient rock entirely the work of volcanoes and atmospheric shifts? Or do they conceal echoes of radiant power once harnessed knowingly? Could the same kind of directed atomic process that nature achieved accidentally at Oklo have been engineered deliberately elsewhere long before us? And if so, could traces of that forgotten brilliance still flicker beneath our feet? The stones do not answer, yet their silence is eloquent. They hold radiation patterns that differ subtly from anything the sun or the core alone can produce. Some say this is coincidence, others call it misunderstanding. But to a few, it is the faint memory of something extraordinary, evidence that intelligence may not be a singular event in Earth's history, but a recurring experiment played upon the stage of deep time. And so we move forward, from nuclear mysteries toward an even deeper enigma, the story of life itself. After all, while energy marks matter, it is biology that records the pulse of progression. In the next chapter, we will journey to the greatest leaps ever recorded in evolution. Explosions of life that arrive too quickly, extinctions that wipe the slate too clean, and transitions that seem almost programmed rather than random. The pattern continues, leading us closer to the secret rhythm underlying creation, destruction, and rebirth on this ancient, remembering planet. The story that began with the metallic whispers of impossibility buried in the Earth's crust now turns towards something even more enigmatic. Life itself. For if matter can remember, then life is the memory that breathes. It changes, struggles, adapts, and sometimes it leaps forward in ways so abrupt that evolution alone struggles to explain it. What force causes the pulse of creation to quicken, only for the same force to erase it again in an instant of geological time? The record of life on this planet is not continuous harmony. It is a rhythm of expansion and collapse, of flourishing worlds followed by sweeping annihilation. Nowhere is this rhythm more mysterious than in two moments separated by hundreds of millions of years, the Cambrian explosion and the Permian extinction. Together they tell a story of sudden brilliance followed by almost total silence. More than 540 million years ago, life transformed from simplicity to complexity with an intensity that defies the slow pace of natural evolution. In what appears to have been less than 20 million years, a blink of an eye in geological terms, almost every major animal group appeared. Skeletons, shells, eyes, nervous systems, and intricate organisms burst into existence, rising from simple microorganisms as though accelerated by an invisible hand. This era we call the Cambrian explosion. The fossil record before that point shows sparse and primitive creatures. Then suddenly the rocks are crowded with trilobites, mollusks, arthropods, sponges, and creatures so strange that their forms defy modern classification. Scientists have long debated the cause. Some speak of oxygen increases, others of ecological pressure or genetic innovation. But none of these fully explain the timing or the rapid coordination across global ecosystems. It is as though biological systems everywhere received the same signal, a synchronized awakening. Could information be woven into the very fabric of DNA, waiting for conditions to unlock it? Could an external influence, a radiation burst, a chemical trigger, or even an intelligent intervention, have sparked this grand acceleration? These questions stretch beyond conventional science, yet their power lies precisely in their improbability. When patterns repeat without clear cause, one must consider that the pattern itself may be meaningful. Then, after hundreds of millions of years of unfolding life, came the great erasures. The Permian-Triassic extinction, which we touched upon before, was the most dreadful of them all. Over 80% of marine species and most land organisms vanished. What took nature hundreds of millions of years to build was undone in less than a million. Coral reefs dissolved, forests turned to ash, and oxygen levels inside the atmosphere plummeted. The exact cause remains uncertain. Massive volcanic floods, asteroid impacts, methane bursts, or perhaps something that eludes current understanding. The isotopic record of that time, as already seen, tells of immense carbon release and radioactive irregularities. It is as if creation and destruction walk hand in hand through the corridors of history. Every age of flourishing seems followed by an age of cleansing, not chaos alone, but precision, as though a reset function were embedded within the living system itself. The Cambrian explosion brought diversity. The Permian extinction erased it, yet from its ashes arose new designs of astonishing adaptability. Each event appears to prepare the way for the next leap. This pattern invites a thought that borders on the forbidden. What if extinction is not merely random catastrophe, but a structured recalibration within Earth's evolutionary process? Could our planet, or something influencing it, act in cycles of renewal more deliberate than we imagine? Such speculation feels audacious, yet the evidence remains. Evolutionary acceleration and extinction pulses operate faster than pure mutation rates can justify. Something beyond simple natural selection seems to orchestrate them. Every extinction, after all, clears the slate, freeing ecological niches, rewriting food webs, and forcing innovation. Perhaps intelligence itself is one of those responses. When conditions press against survival, minds emerge capable of thought, adaptation, and creation. Could this have happened before? If civilizations once rose and fell, if intelligence has walked these paths more than once, then mass extinctions are not endings but intervals in a repeating story. The fossilized gaps could then represent not absence, but aftermath. Many paleontologists have noted peculiar bursts of specialization just before catastrophic collapses, as though life, sensing some impending transformation, accelerates its own experimentation, a final surge of creativity before the curtain falls. The fossil beds in such layers appear chaotic yet strangely purposeful, as if nature were rushing toward a destination unknown even to itself. Then silence. For millions of years, silence. In the aftermath, entirely new life forms emerge, with traits never before seen. Genetic studies reveal that these transitions often require mutations and adaptations too complex to occur by chance in the available timeframes. One might compare it to skipping evolutionary steps, like a manuscript receiving entire new chapters without the drafts that should have preceded them. Such leaps perplex those who seek gradual continuity. Perhaps nature is not gradual at all. Perhaps it is episodic, responding to signals written into its own molecular code or imposed by forces beyond the visible biosphere. This recurring pattern, creation followed by erasure, resembles the rhythmic pulse of a vast experiment. Life rises, accumulates knowledge in biological form, and then resets, leaving traces so faint that later ages can only guess what came before. Intelligence, then, might not be a human monopoly, but a recurring expression of the planet's deeper potential. If so, extinction is both tragedy and design, a way to restore balance after excess or error. The mind stumbles at these possibilities, but the evidence endures. Each fossil layer, each extinction event, each comeback of life points toward a system that evolves in cycles measured not by centuries, but by epochs. The Cambrian spark and the Permian silence are chapters of the same narrative, one of experimentation, destruction, and rebirth. That cycle continues, unbroken. When we look at this repeating pattern, we must ask, what force dictates it? Is it planetary, cosmic, or something woven into the biology of life itself? The Oklo reactors showed us that nature can be a physicist. The evolutionary record shows us it can also be an artist. Together they imply an order so intricate that even chaos seems to obey design. If the ancient metallic spheres hint at purpose in geology, and isotopic fingerprints hint at memory and chemistry, then these evolutionary leaps suggest intelligence encoded within biology itself. The question remains, whose intelligence is it? The Earth's own, a cosmic influence or remnants of beings who once knew how to awaken and erase life at will? The mystery deepens. For now, we look ahead. The next evidence does not lie in fossils or isotopes alone, but in the materials that should never have existed. Metals alloyed with precision before metallurgy, polymers too complex for nature, crystalline habits that speak of simulation rather than sediment. In these discoveries, we find ourselves staring not at evolution, but at technology sleeping in stone. From the atomic echoes of nuclear mysteries and the rhythmic rise of life through creation and extinction, we now arrive at evidence that lies beyond organic story or geochemical record. This is the domain of the artifact, but not the kind shaped by known human hands. Here we find metallic precision, artificial pattern, and complexity frozen inside the Earth itself, from epochs that predate every known civilization. These discoveries whisper of technology buried deeper than history. The first hints emerged quietly. Geologists studying ancient rock cores noticed minute metallic spheres, polished to impossible smoothness, embedded in strata that by all standard dating methods are tens of millions of years old. The instruments that measured their content revealed alloys of titanium, nickel, iron, and platinum, metals that rarely coexist naturally in such pure and balanced ratios. Some spheres are smaller than a grain of sand. Others are visible to the naked eye, yet all share near-perfect symmetry. Natural volcanism, meteor impacts, or sediment melting cannot account for their striking uniformity. They appear engineered rather than accidental. Under the scrutiny of electron microscopes, these spheres display lattice arrangements, suggesting controlled crystallization. Atomic ordering achieved through conditions of extreme heat and directed cooling. In metallurgy, such patterns are hallmarks of deliberate synthesis. Yet the geological layers encasing them solidified long before the earliest known human use of metal. The contradiction is stark. Materials requiring temperatures exceeding those of volcanoes exist in deposits formed before mammals had even emerged. The question arises, who or what forged them? In some deposits, these spheres are not alone. Tiny fragments of unknown alloys sometimes accompany them, formed from combinations of metals exceedingly scarce on Earth. Platinum balanced with iridium, iron blended with vanadium, rare earth elements in ratios that mirror high-performance industrial composites. Under laboratory spectroscopy, they exhibit precision beyond what random fusion of minerals could achieve. Some are magnetic in symmetrical patterns, others conduct heat as efficiently as modern aerospace materials. They suggest not accident, but intention. Perhaps even stranger are the synthetic polymers discovered in ancient sediments. Long chains of carbon molecules woven with silicon and fluorine, appearing in structures vastly more complex than any naturally occurring organic molecule. These polymers were initially dismissed as modern contaminants, introduced by drilling tools or machinery, but deeper excavations, performed under clean conditions far below any layer accessible to human industry, revealed identical materials trapped within mineral crusts dated to millions of years. The configuration of their molecular bonds shows properties known only to engineered plastics developed in recent decades. Nature has no mechanism to produce them spontaneously. Under ultraviolet imaging, these polymers reveal layer arrangements reminiscent of carbon fiber composites, with alternating regions of rigidity and flexibility, exactly the kind of structural control found in designed materials created for endurance and heat resistance. Some were discovered alongside metallic residues that suggest melting and reforming processes similar to industrial manufacturing. Every test to explain them as natural fails against the cold logic of their chemistry. The Earth does not polymerize molecules in such patterns on its own. When viewed collectively, the spheres, the alloys, the polymers, they sketch an outline almost too startling to accept, that advanced material engineering once occurred during periods when no identifiable species capable of technology existed. These findings emerge from isolated corners across continents, each buried under unbroken layers of rock, untouched by subsequent disturbance. Statistically, the odds of such precision forming naturally in multiple locations are beyond improbable. It is tempting to imagine them as relics of meteor impacts, fragments of unknown extraterrestrial bodies, yet chemical comparisons weaken that defense. The isotopic signatures of many samples match terrestrial origin. They were made from Earth's own elements, not those carried across the void. How could a planet craft its own artifacts if no craftsman was present? Skeptics argue that unusual conditions might account for the anomalies: lightning strikes transforming sand into glass spheres, magma fractures generating localized crystallization, or bacterial films creating mineral films with deceptive order. Each explanation works in isolation for one case, but fails collectively for all. The alloys show evidence of smelting. The polymers require precision-controlled sequences to exist at all. Together they defy geology. If we connect this evidence to the deeper pattern already unfolding, isotopic irregularities hinting at forgotten events, evolutionary leaps reminiscent of guided design, nuclear reactions echoing modern reactors, then these materials are no longer random curiosities. They become fragments of a larger picture, the materials that remain when intelligence outlives its memory. The planet hides not just fossils of life, but fossils of science. One might imagine a civilization preceding our own by tens of millions of years, forming technologies from the elements available to them, building devices and structures that time has since reduced to dust. Metal corrodes, cities sink, tectonic shifts bury memory. Yet the materials persist, silent, immutable, too durable for nature to erase entirely. They wait in the rock like punctuation marks in a forgotten paragraph of history. If that possibility unsettles the scientific mind, it is because it strips away the privilege of uniqueness. It suggests that intelligence may not be an accident of evolution, but an inevitable response to conditions that arise again and again. Each cycle of life might eventually evolve creators, and those creators, in their searching, may repeat familiar errors, reaching for mastery, unleashing energies too great, then vanishing into geological silence. What remains is the evidence that resists decay. The texture of these materials also raises questions about their original purpose. Were they parts of machines long eroded, instruments buried by catastrophe, or structural remnants of cities now metamorphosed into stone? Their microstructure implies engineering beyond survival, design aimed at durability. What need required such permanence? And if they were built to endure, what event overwhelmed even that endurance? Some researchers privately speculate that these ancient materials could represent experiments in synthetic matter, attempts to blend organic and inorganic forms. Certain samples contain traces of carbon chains linked with metallic nodes, suggesting hybrid materials capable of self-repair or adaptation. If true, they may belong to a science still beyond our grasp. What if life itself, at its highest form, was once fused with technology, a union of biology and engineering lost to extinction? Every discovery adds weight to the central question: are we truly the first, or are we only the latest, to stand upon the same precipice, a civilization glimpsing the limits of creation before being folded back into the stone? Each recovered sphere, each engineered polymer, each anomalous alloy carries a message older than language. They whisper that we may be walking paths once trodden before, without memory of those who came first. And perhaps that is the final irony. We search through stone for evidence of others, not realizing that one day our own artifacts will become theirs, anomalies in a future epoch, where new eyes will wonder how such materials ever existed. The cycle continues, and the Earth remains the archive. Yet one question now burns brighter than ever. If the past could forge technology we still struggle to comprehend, then what power erased it? The answer may lie not in matter, but in the planet's memory, a memory written in climate, in atmosphere, and in the lessons of collapse that echo toward us from deep time. The story that began with metallic anomalies buried in the oldest stones of the Earth now reaches its quiet and sobering conclusion. For if matter remembers creation and destruction, and if life itself records its cycles through evolution, then the sky above and the ice beneath remember everything else. They are the diary of the planet, the living memory of its breath, and through them we hear the faint echo of every civilization that rose and vanished before us. In the cold silence of the polar ice lies a record as detailed as any written chronicle. Each flake of snow that fell thousands of years ago captured a trace of the air that surrounded it, bubbles of atmosphere sealed away in crystal. By drilling deep into these frozen archives, scientists have extracted cylinders of ancient ice that tell a story stretching back almost 1 million years. Within these pale blue layers is the unbroken record of the Earth's climate, pressure, and composition. What it reveals is both astonishing and terrifying. For hundreds of thousands of years, the levels of carbon dioxide, methane, and other greenhouse gases remained remarkably stable. Climate oscillated in predictable waves, warm interglacial periods followed by deep freezes, but the pattern was steady. Then, in the blink of geological time, everything changed. The ice shows the first sharp surge beginning around the early 20th century. Carbon dioxide began climbing beyond all historical limits, and temperature patterns followed. Today, that rise continues with accelerating force, the atmospheric concentration over 40% higher than at any time in the last 800,000 years. It is not only the speed of this change that alarms scientists, but its resemblance to patterns buried deep in the past. Other ancient spikes in carbon concentration correlate precisely with cataclysmic climatic shifts, mass extinctions, oceanic stagnation, and the collapse of ecosystems. Each event rewrote the course of life. Now, as history repeats in slow motion, humanity stands within the same pattern that once marked the end of worlds. Sea levels are rising again, glaciers retreating, and ocean currents shifting their ancient routes. The rhythm of rainfall and drought has grown erratic. Some civilizations have already felt the sting of this imbalance. The Maya, the Indus Valley cultures, the ancient empires of the Middle East all flourished under stable climates, and all declined when droughts became relentless and rivers failed. Archaeological remains tell the same story in every corner of the world. When the sky changes, society trembles, crops wither, trade halts, cultures fracture, and knowledge decays until memory itself disappears beneath sand and vines. The warning is not only written in relics, but in ratios. The oxygen and carbon isotopes trapped within ice cores reveal that every major climatic upheaval followed an exponential path. Slow beginnings, then a sudden, irreversible acceleration. Just as ancient technological signatures were erased by their consequences, the signs of our own progress may already be carving the epitaph of the current age. If civilizations before us existed, perhaps this was the mechanism of their end, the unbridled alteration of the planet's delicate equilibrium. The United Nations and numerous observatories around the world warn of a rise of 3 degrees Celsius by the end of this century if current trends continue. To many, that figure sounds small, yet the Earth is exquisitely sensitive to such shifts. A rise of even 2 degrees can melt ice caps centuries old, flood coastal cities, and redraw continents. History has shown that ecosystems collapse long before the oceans reclaim the land. The chain begins quietly, in the oceans where plankton falter and coral bleaches, and ends with failing harvests and mass displacement. The collapse of complex systems follows the same curve, whether biological, industrial, or societal: growth, tension, overshoot, and fall. Throughout our exploration of Earth's forgotten depths, a single theme has repeated. Every time intelligence touched the world, whether through nature or through sentient design, the result was transformation followed by loss. The metallic spheres buried in stone, the isotopic anomalies locked in ancient rock, the nuclear patterns, the evolutionary leaps, and the engineered materials all speak of rise and erasure. Now we watch our own society altering the planet at geological speed, inscribing a new layer into the record. Future scientists, perhaps not human, might one day study this layer and ask the same question that we ask of the past. What happened to them? The past offers clues if we are willing to read them. In every extinction event lies an echo of technological collapse, not necessarily of machines, but of imbalance. When energy use outpaces equilibrium, when a species reshapes its environment faster than it can adapt, The pattern ends the same way. The Earth restores itself by resetting the conditions of life. The planet has always survived. The question is whether its current inhabitants will. Yet there is still choice. Awareness itself may be the evolutionary leap this time. Unlike the vanished civilizations that may have preceded us, we possess the ability to see the pattern as it unfolds. Ice cores, satellite data, and deep-sea sediments form the mirror in which we glimpse our reflection across time. We can either repeat the fate written in stone or change the script before it concludes. Understanding the enormity of that choice requires humility. The grandeur of our technology must bow before the permanence of nature's cycles. The forces that once shaped continents and erased empires move again beneath our feet and above our heads. Already the jet streams twist in unfamiliar currents. Already new deserts bloom where forests once stood. The Earth does not rage, it remembers. Its climate responds not in fury but in balance, seeking a new, steady state even if that means doing so without us. Science records this not as myth but as measurement. The rising parts per million, the melting kilometers of ice, the degrees added to each decade's average. Numbers that once lived only in computer models now appear in the headlines of every day. Yet behind those numbers lies a simple truth echoed by every layer of rock and every breath of air. Nothing that violates equilibrium endures. If we listen carefully, the entire planet seems to whisper its lesson. The ancient metallic artifacts warned of mastery without wisdom. The isotopic scars told of burning too bright. The biological record showed how easily life can vanish and begin again. The synthetic materials buried in forgotten epochs revealed how permanence can vanish in oblivion. And now the atmosphere itself, fragile, transparent, immense, is speaking in heat, in storms, and in silence. It is telling the same story in real time. Perhaps that is the true purpose of the evidence scattered through deep time, not to prove that others once existed, but to show that the boundary between creation and extinction is perilously thin. The civilizations that may have risen before us are gone, not because they lacked power, but because they used it without balance. In their ashes, we are given a mirror. We stand now where they once stood, a species aware, yet uncertain, holding in its hands both the means to destroy and the chance to preserve. The Earth's memory stretches far beyond humanity, but within that memory lies hope. For memory is not only record, it is guidance. If we can learn from it, if we can listen to the voices of stone, carbon, and ice, then perhaps the story need not end as the last did. Perhaps we can become the first civilization not to vanish into geological silence, but to join the rhythm of the planet in harmony rather than conquest. The warning has been carved not by prophets but by the planet itself. The evidence is everywhere, in the air we breathe, in the archives of ice, in the relics beneath our feet. The question that began at the dawn of this journey returns once more, now reframed not as speculation but as decision. Were we the first or just the latest? The answer depends on what we choose to become in the fragile moment that remains between memory and forgetting.